Hello again. Today we're going to be talking about definite integrals that involve substitution. We've talked about integration by substitution before, but now we're going to talk about a way to shorten the process if you have definite integrals. So let's get started. If you remember when we had indefinite integrals, what we would do is we would let u equal something, and then we would find what x would equal in terms of u, just in case we needed to replace that as well. And we would figure out what du is, and if possible, figure out what dx was, so that we can make a nice substitution so that everything is in terms of u instead of x. So that's what my integral would look like after I make those substitutions. I would then distribute the square root of u into those parentheses and get an integral that I could find the antiderivative of term by term. So I would integrate that to get 2/5 u to the 5/2 minus 2u to the 3/2 plus a constant. So then what I would do is, because that integral is in terms of u, but the original question was in terms of x, I would have to go back and I would have to replace every u with x plus 3, and I would get my final answer there. All right, if this was a definite integral, so let's say I had endpoints of x equals -3 and x equals 0, what I would do afterwards is I would take the antiderivative that I got and plug in those two endpoints, and I would get 2/5 times 3 to the 5/2 minus 2 times 3 to the 3/2. But there is an easier way if you have a definite integral. So let's talk about that. All I would need to do is substitute the endpoints as well, because remember, those endpoints are x values. And so what I could do is, if I changed everything to be in terms of u instead of x, then I could change the endpoints to be u values instead of x values. So since u is equal to x plus 3, I could replace x equals 0 with u equals 3, and I could replace x equals -3 with u equals 0. So then I would have a definite integral that goes from 0 to 3. I would find the antiderivative in terms of u, and then I would be able to plug in the 0 and 3, because those are u values that I could plug into that antiderivative, and I would get the same answer. All right, so let's try another one using this same process. So I have the integral from -pi/4 to +pi/4 of sine squared x times cosine x. So I'm going to use a u substitution. I'm going to let u equal the sine of x, and du is going to equal the cosine of x dx. So that's a nice clean substitution. But before I continue, I'm going to look at those endpoints of -pi/4 and +pi/4, and I'm going to plug those x's into the equation u equals sine of x. So when x is -pi/4, u is going to be the sine of that, which we know is -√2/2. And when x is +pi/4, u is going to become the sine of that, which is +√2/2. So now I have a definite integral that is expressed entirely in terms of u, including the endpoints. So I simply need to find the antiderivative of u squared, which is 1/3 u cubed, and plug in those endpoints, which are u values. So I plug those in, and I get that expression there, and I can simplify it if I need to. And so my answer would be √2/6. And that is the process. It's a simple matter of just changing the endpoints to u values after you've done your u substitution, and then just finding the antiderivative without the need to change everything back in terms of x. Now, it's not wrong to change everything back in terms of x. This just saves you a step in the process. All right, so if you have any questions about that, please let me know, and I will see you tomorrow.